So let's go to Q&A session. Let's go to Jeremy Reese, who already has his hand up. And Jeremy, I'm not sure if your YouTube feed is on or not. I just tried to message you about that. Oops, sorry about that.
There we go. All right.
Yeah, my fault.
Yeah, I had a problem. I'm watching my son, and he must have hit the computer screen and shut the StreamYard down. For the most key part of that, it was like started off, it was like, oh, all right, we're going to talk about Bob Lazar, and then 10 minutes of blank screen, and then also and then it was on the summary page when I got it back up. So everybody missed like watching live. I lost like 100 people watching it, and yeah, I'm sorry about that, but I will repost that when you get it up. I'll have to get the link, and I'll have to repost that presentation from Riccardo because of the technical difficulty and the glitch. And I do apologize. It was totally not like intentional in any way, and I'm sorry that happened. But I wanted to have a couple questions about the presentation because I was watching it and I was paying attention, even though it wasn't on for everyone else. I just want to point out that my first question is there was a gravity A wave and a gravity B wave. And did you mean gravity? You said gravity A wave in both cases, and did you mean gravity B wave on one of those, or?
Okay, so yeah, so look, I'm not sure where perhaps I might have miscommunicated, but I'll try and clear that up. A gravity A wave is emanating from the moscovium atom itself. The gravity B wave is emanating from, in our case, the Earth. So that's the difference between gravity A and gravity B. These are Bob Lazar's words, not mine.
And I had never heard that actual 7.24 hertz or whatever figure before. Did that come from Bob Lazar, or?
Yeah, that came from Bob Lazar actually back in 1989, so over 30 years ago. And it's the most easily and most trivially verifiable number just by using Fourier series.
That's the Schumann resonance, right?
No.
Not close to that. It would look like a
similar. Well, it's close to it. It's close to it, but it's not it. I mean, as I understand the Schumann resonance, that's not it. It's close to it, but it's not it.
I'm trying to think. Like another person said, "Oh, it wasn't Bob Lazar's claim. He hijacked it from somewhere else." And did you do any research into the literature to find if anybody, if he could have got these claims from somewhere else and simply been repeating them, or did these claims originate with Bob Lazar?
They originated from Bob Lazar, to the best of my knowledge. I have not seen them anywhere else. In fact, the 1991 video by Gene Huffman and Bob Lazar quoted it then, I think, from memory. So I've certainly not seen it anywhere else. And look, I mean, in some sense, even if it did come from somewhere else, okay, it's relevant, but it still doesn't take it away. It doesn't take too much away from the gravitational story that's involved with that first claim. But yeah, to the best of my knowledge, he said it.
Wonderful. Jeremy, was that everything? Or
yeah, I'm gonna have to go look at the source for that and go track that one down, because I wasn't aware that he gave that kind of an exact figure anywhere. So I want to go and find that.
Okay.
But, I have to give a shameless self plug to let people know that it's still streaming on YouTube uninterrupted on my Crypto Alchemist channel. But me and Jeremy will be figuring out in the future better where these streams will just go to multiple channels with zero interruptions.
Okay.
Yeah, Bernard, give me a link. I'll post it so if people want to immediately go watch it right now, they can go to your channel and go rewind 10 minutes and check that out.
Awesome. Thank you. Okay, so let me go to Mark next. Mark, sir?
Yeah, I got a question for him. I'm trying to figure out from this Bob Lazar model here, maybe you can help me understand. He's using a gravity wave, or the UFOs or the ETs are using a gravity wave. How do you get from this gravity wave to anti-gravity or gravity shielding and propulsion? How does the craft move using this system that Bob Lazar explains?
Yeah, well, apparently, and I'm just repeating what Bob Lazar has described, but apparently there are 3 gravity amplifiers on board this craft. So, and they're spaced 120 degrees apart. If you can imagine a plan view, 120 degrees apart. Now, in the middle, there's the actual power source, and that's where the Moscovium wedges, right? Assuming that stable Moscovium actually exists, a stable isotope exists, that's where the Moscovium wedges go into an apparatus in the center. So, and around that, you've got 3 amplifiers at 120 degrees spaced apart. On the next layer beneath that power generation layer, the next layer underneath the spacecraft, you've actually got 3 conduits that are able to move in different directions, have all kinds of orientation. So at the surface of the Earth, if it was a hover situation, apparently according to Lazar, it can sit there using one single amplifier if you're just hovering there. However, if you are wanting to go somewhere with it, say somewhere out in space, those conduits or those horns can rotate, can focus on, all 3 of them can focus on a point in space, and basically, according to Lazar, generate you downhill. And in his 1991, and you basically just keep falling downhill. And in his 1991 video, he actually does, he shows it as actually, well, warping space, I will say. It warps space. So, and you basically shorten the distance between 2 points, is the way that he describes it. So that's what he claims, the way it actually works.
So he creates a gravity field underneath the ship.
Yes, correct. And projects it.
Gravity is attraction. So how does creating a gravitational field underneath the ship make the ship float upwards or propel it?
By the gravity A wave that he claims is produced by the Moscovium is then phase shifted 180 degrees. So when it's aimed at the Earth's gravity B wave, it's cancelled out. It's reduced by not greater than 99.9% is what I calculate. So yeah, so that's how he claims it works.
Okay, thanks.
Awesome. And thank you, Mark. Let me see why, sorry. There we go. Okay. Zoom wasn't showing. Oh, because it has the hands up first. Okay, let me go to Sean Logan. Sean?
Go for it, Sean.
Yeah, and Sean, you're gonna have to unmute yourself. There we go. I'll do ask to unmute. And I've got that unchecked, so you guys can unmute yourselves, but please only do so to ask questions.
You gave a frequency of 11.44 gigahertz coming out of the nucleus of an atom. Is that is that frequency an electromagnetic wave, or was that a wave of strong force or something else? And if it was electromagnetic, what's that?
Well, no, good question, right? Good question. And look, all I can say, well, the answer is I don't know, right? What I do know is the frequency. So it's around that. The question is the effect that's coming out of this Moscovium atom. The question is it purely EM, or is it something else? Lazar claims it to be something else. Lazar claims it to be gravity. So gravity to me is gravitational acceleration. So he's claiming that gravitational acceleration is projected like an EM wave, and it can be manipulated like an EM wave. These are his claims. So that's the only way I can answer the question.
But it's a different kind of substance that's vibrating. It's not. You're saying the mathematics is similar to E&M, but it's physically.
Yeah, correct. Exactly. That's exactly right. So the mathematics behind what I've done makes no distinction whether it's EM or something else. It's just a wave, right? Bob Lazar claims that that wave is something else, but behaves like EM. It can be amplified like EM. So yeah, that's the only way I can answer the question.
Okay.
Look, I mean, I don't think anybody really knows.
All right.
Awesome. Okay.
Isn't the element dictates the wave, like the frequency? That's how we categorize elements. Like it's in that frequency range. So we put it in that kind of, it's the frequency of the element that dictates what element it is, right?
No, it's actually the number of protons in the nucleus. So, hydrogen has 1 proton, element 115 is 115 protons. So that's what makes it. And
the hydrogen frequency line is.
Sorry,
but
it's the iterations of that particle.
Yeah, I mean, Lulu, it would have to answer your question. It would have, based on the element, it would have its own resonant frequency, and then you get
its own ups and downs, and that's what they're measuring. The 400 and let's say 12, frequencies, and the equation is, as you stated before, like you divide that by a half, and then it would equal to know that this is element 115.
Yeah. So let me go to Jared next, though. I think there's definitely something to what you're saying about frequencies. Let me jump to Jared real quick, sir.
Hey, yeah, thanks. I had a question. I was following Jeremy's feed right as it cut out good stuff, so I apologize if you already went over it. But on the gravity A wave, you said that Lazar originally got it at 7.46 hertz, and then you guys calculated it at 7.43, close, but not very many, decimal points after that. How did you go about calculating it, and what was any reason for being close but not quite?
Yeah, so okay, so the way it's calculated is just using a Fourier series. So if you take the number 1, you can actually break it down into a spectrum of Fourier harmonics. When you add the first 415 harmonics together, what you end up with is 0.99107 or something like this. What that means is that the first 415 harmonics of the number 1 adds up to 0.99, so greater than 99.9% of the value of the number 1, right? So it's what I call the unit harmonic operator. Now you can multiply that unit harmonic operator by the magnitude of any gravitational field, right? So that's how you relate. So that's how the figure of 7.43 hertz is obtained. Now, why it's not exactly 7.46 as Lazar stated, could be for a variety of practical engineering reasons. Yeah, I don't know.
Cool, thank you.
Yeah. Okay, let me go to, and thank you, Jared. Let me go to Mark next. Mark, welcome back, sir. Mark has been here for a while.
Yes.
Today, been lurking.
Thank you very much for the presentation. About Bob Lazar, there's a distinction that needs to be made. He is telling us how he was told these objects work. He's not saying that this is how it works. He's saying that this is how I was told it works. So even if you take him at his word that he's 100% honest, he's not telling you that this is how it works. He's telling you that this is how he was told it works. So he might have seen something real and been fed a BS explanation as to how it works, because that's the secret. And that's the best way to keep these things secret, is to, spread disinformation. One key fact that is indisputable that proves that something is off in the explanation is element 115 transmuting to element 116, which is antimatter. You can't have a atom suddenly become antimatter. You need antiprotons, antineutrons, or an anti-electrons on the outside, which we call positrons, in order to make antimatter. So making a larger mass of matter doesn't make it antimatter. That's one of the key things. Also, the microwave waveguides that he saw, and he commented that they actually look like microwave waveguides, would be explained by several other experiments that we're looking at, such as the Alzafon experiment that uses microwave waveguides for inertial mass cancellation. Have you considered that possibility?
Look, no is the short answer, because this was about just purely trying to validate his claims against what I know. So this is about discovering evidence for yourself. I mentioned early in the presentation that the only real evidence for anything is that which you can verify for yourself. Doesn't matter if you see it in videos, government documents, it means nothing. It's only what you can verify for yourself. So everything that I've put forward, anybody can verify for themselves, because it's straightforward mathematics.
Okay, what about element 115 magically turning into antimatter?
That's not what actually happens. So Bob Lazar doesn't claim that element 115 turns into antimatter. What he claims is it transmutes to 116, and in the process, antimatter particles are produced, collected, and then I think I'm going from memory here, the antimatter particles are channeled to some gas. Then the antimatter particles annihilate, and then there's a thermionic conversion.
Exactly, 100% thermal electric converter. But the element 116 is the antimatter. You're adding a proton to 115, making it 116, and element 116 is antimatter, which then
the element 116 is.
Yeah.
Well, if I could add some confusion to this as well, I'd like to confuse things even more. I had read, and I could be completely mistaken, that element 115, right, which was super briefly synthesized in a lab, a few years ago, there may be different versions of that, because what Lazar was talking about as 115 may have been an isotope of a different element.
Yeah,
is
correct.
that?
No, he said 115 was that the stable form is an isotope of 115, the 115 element. So what was produced, and hence the name moscovium, is simply one isotope that's known to be unstable or not very long-lived. And just on the point of 116 being antimatter, I'm not sure I understand what that means, because 116, it has 116 protons and however many neutrons.
Yeah,
Sorry.
What I recall reading, and again, I could be completely mistaken, to go to Mark, was the antimatter was supposedly given off when it decays. I remember, yeah, he had and it was a 2 or 3 step process, right? It's 115 to 116, and then it was 116 to like 114 or something like that, and then back to.
I didn't hear about 114. I heard
maybe not, but
we should listen to it again. But my recollection was that it was 116 became antimatter, which then converted with the gas in a 100% thermoelectric conversion process.
116, it decays. It's at so if you look at the reactor, it has a proton beam shooting into the tip. It does a beta decay, which it emits.
Do what?
And it emits a matter, a proton and an electron, right? Or an anti-proton in there. It does an antimatter decay, which I'm sorry, I'm flustered, but it's not that the whole target turns into element, goes all the way up to 116. You're at the very tip of it that you're playing the reactor.
Yeah, that's right.
And you're shooting a single proton into it. It goes up, it's unstable, it bounces up. Bob Greenier found a really good useful website.
Well, it decays to what?
So it's up at element 116 briefly, and then that extra energy decays into a matter and so an electron and a positron, which
Does
is
it go
then
back to element 115?
the target, the triangle target stays, the majority of it stays at element 115. Nuclear reactions are site specific. So you have to think that there's
the atom that got hit went to 116. Does it go back to 15?
As it decays, it emits, the proton that was put into it, shot into the tip of it, it decays into a matter antimatter reaction. So it's a specific type of decay. We can look up on Wikipedia. But
so you're saying that the proton that you're hitting it with became an antiproton?
Because as it decays, there's beta decay, there's you have alpha, beta, and gamma decay, and then
so in that case, the fuel is never used up because the fuel is coming from the particle accelerator, not from the element 115, and that's not
right, possibly.
But that's not what he said. He said that the fuel will last a long time, but it does get used up.
Well, maybe, who knows? Maybe it erodes. Yeah. Maybe it erodes because you're hitting it with a proton beam, right? So,
well, if it erodes, it'll still be there in the chamber somewhere. It'll just break apart, become a powder.
And then Paul Potter also in this book, he goes into the stacking of it, of the fuel element. So that's another resource. So I think that the stacking of that material has been out in his canon, in Lazar's canon for a while. So I don't know if that's exactly new info, but it's.
I mean, one interesting thing is on the periodic table, right above moscovium is bismuth, which is the strongest diamagnetic material. Maybe there's something going there.
Well, Mark, let me bring this back to Riccardo because this is his Q&A session, sir. So Riccardo, what are your thoughts on this?
Look, to be honest, I don't have any thoughts in this space. I focus simply and purely on the claims, those 3 specific scientific claims by Lazar. It seems to me that I think Aidan is certainly on to something. I mean, what Aidan talked about is consistent with my understanding. I don't have a very deep understanding in that space. I haven't focused on it because it's outside my purview. So, and it's very much an open area, open question. There's not a lot of detail around it, and it's complicated by the fact that we haven't been able to reproduce the stable form of that element on Earth. So there are just too many questions about it, I think, to have any degree of certainty. I'm only certain about what I did.
Wonderful. Okay, so let me go to Harold next then. Harold, sir?
Yes, a very interesting aspect what you presented. My question is, what Mark said and Adam Schaefer said, bringing that to what you said, Bob Lazar, the description that is given, makes me think, that there might be a resemblance that when all that energy of 115 is being used, the antimatter given off, that somehow there is an evolution in the process in which it acts as if it were a propellant, and that the energy released from that effect act as a propellant, and that creates a super force that create a very large proportion force. Is there any probability that that is basically what happened in what Bob Lazar described, or what other researchers have investigated, trying to understand how it's happening?
Okay, so Bob Lazar was pretty specific in saying that it is not, there's no Newtonian type reaction occurring. So there's no propellant being emitted out of this. It is, I'll call it electromagnetic, but I only call that, I'm only using that as a description. So no, I don't think that it acts as a propellant in any way. Yeah, that's not my understanding.
I'm making an analogy. You know how propellant produces a force. I know it's not Newtonian, but it's the process itself act as if it were propellant and create a force. I mean, there's no ejection, but there's in the matter antimatter creation, there's an energy release, and the energy release itself, that because the energy, to conserve momentum, something has to give in. You have to put in energy, but the energy itself, just like a propellant create a force, the energy itself in the process create a tremendous, a high proportion force. Is that more like I'm making an analogy, a similarity. I'm not saying that it is a propellant, but somehow an operation of that nature. Would that be what he's describing? Something like that.
Yeah, look, no, I wouldn't, I certainly don't consider it to be a force. If anything, I would probably describe it as bending space-time locally the other way in order for it to just float, right? Bob Lazar does describe the entire craft as being a waveguide. Now, Todd Desiato can pick up on this point if he wants to in greater detail a bit later on. But as Todd has certainly demonstrated to me, and I think probably to other people in the forum as well, the entire craft does in fact need to be a waveguide, because all of space-time in that waveguide needs to be, I'll use the description as bent backwards. So no, there's no force per se that is projected. No, I wouldn't describe it like that, to be honest, at least to my understanding.
Hey, thank you. Great presentation. Thank you.
Thank you as well, Harold. Okay, let me go to Gordon next, sir. Oh, Gordon, you're muted. There we go.
Yep. Okay, yeah, thanks for the presentation. Absolutely superb. Hadn't heard some of that stuff before. I first came across Lazar via BBC, actually, on a program that was on BBC Radio here in UK way back at the late 80s, where some of the claims were made, and then it resurfaced then with the guy that was on that radio show in this book, Alien Liaison, written by Timothy Good, who was a well-known UFO researcher. But Good actually met Lazar along with John Lear, and one of the things that I think was it Mark, I think, was talking about earlier, was this reaction of element 115 to become 116, and it's actually in a little section in this book on page 157. He actually describes what happens, and it says his words on bombardment with protons, it kicks up to element 116, then releases antimatter, and that's reactive with matter, which is then called an annihilation reaction. And it appears they have something like 100% efficient thermocouple of sorts that produces power and some sort of gravitational standing wave that propagates up through the waveguide that you talked about. And they then use that excessive power to do whatever they need. And that was his description of what was going on with it there.
And
may
that's
or may
certainly
not be
consistent
helpful.
with my understanding. You know, that's certainly consistent with my understanding as well. But again, I don't delve into that that antimatter aspect. I've just focused specifically on the 3 scientific claims that Bob's made, and as far as I can tell,
Yeah.
those three claims are accurate.
Yeah.
They're bang on. And the thing is, why I believe what I've done is important is because one can verify for themselves. So I've put all the work out there, and Tim, I think, has already sent the links. But certainly the 7.46 hertz claim, it's just straightforward first year engineering, you know, Fourier harmonics, and it requires no theory at all. You don't need anybody's theory for it. And in fact, if anybody has a theory connected to it, well and good, but it's superfluous. You don't need it. It can be explained totally mathematically. You know, which I think is a remarkable coincidence, because if Bob Lazar knew anything about this, he would have given that as the answer in 1989. I mean, you can't just pluck a number 7.46 out of the air and then calculate for yourself 7.43. You know, it's just, anyway. So yeah. And look, a point that I think Mark made before, which is relevant, I think it's an important point, is that much of this information that Bob Lazar has passed on was given to him in briefing rooms, right? And much of it, or some of it, not much of it, some of it may in fact have been misinformation, in order, you know, as a security measure and stuff like that. And I believe in the 1991 video that Gene Huff and Bob Lazar did together, so only 2 years after he came out with his story, I remember watching it live on TV back in 1989, and just to show you my age. If you watch that 1991 video, I think it's about 39 minutes long or something like that. Towards the end, I think he calls it section 2 or something, towards the end of the video, the last few minutes. He talks about aliens and how many times they've possibly interacted, you know, or controlled the destiny of our species. I think all of that is just utter rubbish. I think that is the misinformation, right? But certainly the technical aspects, I have verified to my personal satisfaction, absolutely, and everybody else can check. You know, you can plug the numbers in yourself. I've created a spreadsheet calculator to make it really easy for everybody. You can play around with the numbers, change the formulas, do whatever you like. Yeah.
Okay. Thank you, Gordon. Okay, so let's go to Morgan next, sir.
Okay, so just I guess a couple of comments on this. The idea that you're using this this heavy element, this 115, as I forget who had mentioned this, that if you're bombarding this thing with some proton beam or some particle beam, that whatever's supplying that particle beam is essentially the fuel. And what Bob was saying, or Bob Lazar was saying, is that it's the element 115 that's itself the fuel. And to me, that sounds almost like it's some sort of kind of like a nuclear reactor of some sort, whatever, a cold fusion or something like this. But whatever process is going on, that's the thing that's generating the energy, and that's going around somewhere and powering the systems and things like that. And it seems like that power source is powering some other thing that might be generating a gravitational field or some sort of anti-gravity field, whatever, if it's this Gershenstein mechanism or some other kind of crazy thing. But it seems like that it's the actual the element that's itself. So whatever process is going on with this 7.4 hertz hitting this element, that seems to me like it's more of a power source. And then there's some other thing happening that's creating the gravitational field. I don't see how a heavy element can create a gravitation. You know, we talk about this gravity field A as if it's somehow leaking out of the nucleus or something like this. The only thing that seems at least somewhat plausible is if it's some sort of near field effect. You know, you get these really intense near fields in electricity and magnetism, if you have a, like, say a whatever, like a plasmon or some particle confined to some surface, you get this exponential tail, which is really strong, which might be what's happening here, but I don't know how if you can confine a particle to get a gravitational field like that. But I don't know, just a couple of comments on that. Go ahead.
According to Bob, so I'm using his own ideas. I'm just repeating them. He believes that the strong nuclear force within the nucleus of 115 actually is an isolated case of where the strong nuclear force actually, to use your words, leaks out of the nucleus to such a point where we are able to grab it and amplify it, right? The strong nuclear force. This is what Bob Lazar believes. It's not what I believe, but it's what Bob Lazar believes. So that, look, I can't speak to the point whether that's actually happening or not. All I can do is say that I've run the numbers for myself on what Bob's talked about, and it seems impossible to me that he can just guess 7.46 hertz tied to a microwave frequency range amplification system, tied to an element that requires a very specific process that can all be explained. It can all be explained by the 11.44 gigahertz frequency. So the microwave frequency range value that I've come up with, that's not a Bob Lazar value, that's my value. His value was 7.46, he came up with that. So to me, these things have convinced me that those three claims are accurate.
What was your number, the 7.43? You were doing this Fourier decomposition with this 400 and some odd harmonics. What with some gravity field? What exactly was that? Well, what was it? Your Fourier transforming something, or what is this?
Yeah. So so if you take just the number one, right, and you actually break it down using a Fourier series analysis, so you can actually break it down to a number to harmonics, right? So, well, when you sum the first 415 harmonics, when you sum all those harmonics together, and I show it on the slide, and you can see it on the ResearchGate paper as well. When you sum them all together, what you end up with is basically greater than 99.9% of the value of one, right? That actually relates to a frequency value. So you can transform that into a frequency value of 7.43 hertz, right? So Bob said that the three horns under the spacecraft pulsed at a frequency of 7.43 hertz. So they would pulse at a frequency of 7.46 hertz, pardon me. They'd pulse at a frequency of 7.46 hertz. But from each one of those horns came a burst of microwave frequency range energy. And I've calculated that to be 11.44 gigahertz. So, yeah, that's basically it. I think there are some animations available in various spots around the web that can show you that. But essentially, from the moscovium element comes a signal that extends outside the nucleus. That signal is grabbed and amplified. I'm saying amplified to 11.44 gigahertz, and that's in the microwave frequency range, which is what his claim is, not the 11.44 gigahertz. That is then burst released through horns at a frequency of 7.46 hertz is his claim. And by the way, I've run a number of scenarios around element 115, whether it was element 116. So whether the number of protons, etc., change, or even the number of neutrons change very much. It doesn't. So I've experimented. I've done some what ifs, and in all situations, I've found that the frequency for amplification coming out of that is always somewhere between 10 and 12 gigahertz. So if this effect, if this phenomena that Bob describes is genuine and some of his numbers are a little bit off, right? It doesn't really matter, is what I'm saying, because it's always going to be somewhere between 10 and 12 gigahertz, something like this.
There was, I guess, just a final comment. I forget the details of this one, but someone had mentioned that about how gravity B is a strong nuclear force. There's some people have been working on these things where I guess you could, if you look at a quantum field theory of gravity, you can essentially, I don't know exactly how this works, but it can decompose into two copies of QCD. There's some decomposition that you can do with that, where you can, you could write a general relativity theory as two copies of QCD, which that might have to do something. At least in that case, you have some strong nuclear force being attached to gravity in some way. So maybe that has something to do with it as well. But okay, yeah, cool. All right, thank you.
Yeah. Cheers.
Wonderful. Okay, so let's go to Robert next. Robert, who has been patiently waiting. Sir?
Yes, I'm still trying to get my head around element 115 being stable. Right. These heavy elements are typically have very short half-lives. Now, does anyone know the number of neutrons that would give you the isotope of 115? That, you know, the protons plus the neutrons would be related to the atomic weight. And you could figure that out. You could measure it by putting this isotope of 115 through a mass spectrometer, so it's knowable at least.
Okay, look, that's a really good point. The answer is nobody has the answer. There is theoretically an island of stability, and I think from memory, the number of neutrons, I think it's around, from the diagram, and the diagram's actually on one of the slides that I've presented. I think it's around 180 or something like this, roughly, but no one's actually got the answer as far as to my knowledge. Yeah.
Okay.
If it's possible at all. Yeah.
Well, I mean, it should be knowable. I mean, if they did experiments on this, they should have put it through a mass spectrometer, and then they would know the atomic weight.
Yeah. Yeah. So the thing is, the element 115, or the moscovium that Bob claims he had, well, I mean, that's just a claim. In terms of our human discovery of 115, you know, I think 650 milliseconds, I think was its life, something like this, its half-life. Yeah. Something like this. So there's certainly been no chance for us to put it through a mass spectrometer. But look, yeah, you would think that someone on the Bob Lazar end would have done that, and that may very well have been done, but not information that was revealed to Bob. Possibly.
I don't see how you could use it unless it's stable somehow. So you need an.
That's right. Yeah. Yeah, that's right. So Bob Lazar claims that the US government was supplied with about, I think, 223 kilos or something like this of element 115 by the Martians, by the space aliens, right? So this is his claim that the US government has that kind of material in reserve. And you would think that someone would have done some kind of analysis to determine the number of neutrons for the stable isotope. Someone probably has, right? It seems inconceivable that wouldn't be done. But that information probably was not provided to Bob Lazar, because why would he need to know it? Right? If you're an engineer playing around with it, right? Why would you need to know that?
I don't know.
Right.
That
All
could
you'd
be
need to know
critical
is-
to why it works.
Well, it could be, but if, at least to my way of thinking, if you're trying to minimize the escape of this information for whatever reason, it's look, it was not remarkable to me. I mean, the media on the internet has often made the claim, "Oh, Bob Lazar predicted, 115 before we'd actually discovered, etc." That was not an amazing claim to me at all, right? It's just obvious. It's bound to happen, right? It would seem to me that someone who's trying to keep that information from the public, right, would realise that a critical piece of information would be the number of neutrons. So you wouldn't need to pass that on, because if you know what the stable number of isotopes is, right, when we eventually discover it and we find that it's unstable the way we discover it, well, then that kind of puts a hole in Bob Lazar's claims, doesn't it? But if you release the number of neutrons, Bob can say, "Oh, well, yeah, that's obviously not, because it's, we haven't made the same stuff." So yeah. I can see reasons why it wouldn't be made known to him.
That, and the fact that, I mean, this is our government. This is the American government, right? So yeah, I will not use the word incompetent at all. I refuse to use that as a descriptive term. But well, okay. So let me go to Michael Boyd, who has something levitating, which may be element 115 right there. Michael, I've done the build up. I've done the build up. Oh yeah. Can you unmute yourself, sir?
No, you'll need to unmute.
Oh, Michael, you're still muted. Okay. There we go. Is that 115 right there?
My nuclear reactor was down, so I couldn't work on that. But I do have here. So basically, gravitomagnetism is what my background's in, and basically my thoughts on anti-gravity is that it's a combination of both gravitomagnetism and acoustic properties. And what we have here is what's called an acoustic levitator. And what that little object is there, in the middle of my neck that's spinning around, is a piece of styrofoam. And so basically it's a combination of vibrational energy, which is basically where the protons are moving, and a type of magnetism called gravitomagnetism.
But is it special styrofoam made out of element 115?
Here, it's a piece of a peanut, like you get of styrofoam that you put in your packaging.
Oh my God, the aliens use packing peanuts? I had no idea. No wonder they're trying to keep it secret. Everybody could use this.
Oh, you're going to have to cut this from the.
I'm sorry. I'm kidding you. Well, Michael, what was your question for Riccardo?
Well, what's his thoughts about it being something a lot simpler than what Mr. Lazar is describing?
Look, I tell you what. If you can turn that horizontally, is that styrofoam going to drop to the ground?
I don't know. That's a good question. Probably.
Oh, moment of suspense.
Oh, yep, it falls out.
Okay, there you go. If you can make that stay where it was horizontally, then you've got Bob Lazar's. You've got an answer for Bob Lazar, because it's not the same thing. What you're talking about, that what you've demonstrated, is absolutely not the same thing at all as what Bob Lazar was talking about. No disrespect, but it's just. It's not.
That's okay. I don't take any disrespect.
Michael, I will never trust styrofoam again. I feel like I've been betrayed. It seems so innocuous until you realize that it's all just a lie. So,
well, that's the thing about Bob Lazar is you know, I have compassion for him, but I want evidence. I can show you evidence of styrofoam levitating. You saw it. The stuff that we're talking about with
that's not the same thing.
Lazar is what's the evidence?
Yeah, I mean, no, Riccardo, your analysis is different than, or maybe it's not. Is it different than your personal opinion, or?
No, it is. Look, so my whole point is that, and Michael's touching a really good point here, right? It's about showing you the evidence. Well, my point is, I've given you the evidence. You can check it out for yourself, right?
Well, would you be more specific, please? I don't understand. I can see the evidence. Is there a website or something like that?
Yeah, sure.
Okay,
yeah,
would you put it in the chat so that we could check it out?
Yeah, and I think
Tim's done that.
Sorry, actually I do. On the conference page at the bottom of the page, I have a link to the ResearchGate paper. But
okay.
So Riccardo, if I could maybe rephrase, I guess, what you're saying, and I might be incorrect. What you're kind of saying is like, okay, if someone says, you know, aliens told me there's a buried treasure on this island in the Pacific, right? And so you go to that island and you find the buried treasure, and maybe it's not in exactly the spot, but it's pretty darn close. Then that adds some evidence. Is that sort of kind of?
That's right. So what I'm to be very precise about it, Bob Lazar makes one very, very specific claim, right? That until now has been inexplicable to my knowledge. If someone else can show me how a value of 7.46 or something close to it comes up in the description of gravity, I'd be happy to see it. But what I've demonstrated is that 7.46 answer is no fluke, and you can get it using basic first year engineering Fourier analysis. And that's it. And everybody can reproduce it for themselves, provided you understand a little bit about mathematics, right? So there is no better evidence, right? That's better than video evidence that you might see, which can all be doctored, right? Evidence that you can check for yourself. That's the only kind of evidence. So
I agree. I'll check it out. Thanks for answering my question.
Yeah, sure.
Well, and thank you as well, Michael. Let me go back to Jared. Jared, sir.
There we go. Yeah, I had a follow-up question on the 115. On the paper, it looks like you are ignoring the electrons in a lot of places.
Yeah, that's
sure.
Right, yeah.
A lot of reasons to do it. I was curious though, if you're hitting the very tip of this piece with protons and stuff, and we're dealing with, you know, resonances all over the place, wouldn't the lattice structure of the sample be important? Wouldn't the number of electrons and their binding be important for all these calculations?
Look, possibly, right? The short answer, I believe, is no, because if it were, I don't think I would get the results confirming what Lazar has claimed, or if the only claim that it may have an effect on is possibly his second claim. So I've come up with a result of 11.44 gigahertz, and I did that ignoring electrons. Absolutely, that was just to simplify it. It could make a difference, but my personal view is I can't imagine that it would make much of a difference personally, because the effect, the anti-gravitational effect, and I hate using that word anti-gravitational, but the anti-gravitational effect is coming from the nucleus, not from the electrons. Right?
Well, especially if there's like positron decay, right? And that's definitely going to be slamming into all those balances, right? You're going to have all sorts of weird interactions going on when you're getting decay.
Possibly. Look, it seems to me impossible to do a deep and exact analysis, engineering analysis of anything, because there simply isn't enough information, right? So look, I did my best with what was available, basically. Yeah. So
Yeah,
you could be right.
Yeah, yeah. Well, and yeah, I mean, I think, yeah, Riccardo, I don't think anyone could criticize you for, you know, incomplete information. I mean, that's something that we all work with, right? It's, you know, it's bits and pieces that we get here and there, and God knows what we're missing, and, you know, so yeah, you know, let me go to Bernie, who is, I can see the look on his face. He's eager.
So a common theme I'm noticing with the Bob Lazar topic is that he seems to come up with these over elaborate necessities and complexities to his designs. For instance, his hydrogen powered car that needs and requires a particle accelerator in his backyard to make an aspect of it. Yet it's like, I'm making this same HHO Brown's gas out of salt water and 5 volts in my backyard that anybody can turn salt water with a small amount of electricity into these gases like Stanley Meyer was, where you don't need these insane things. So it's that, sure, Bob stumbled upon what would be like the Star Trek sort of scenario where it seems like he discovered or claimed these things before they came out, but it's just an inevitability in some of these far-reached sci-fi sort of ideas it seems he's come up with, but there's zero actual evidence of anything that he's claimed come forward with showing the actual technologies.
Look, just on the point of the particle accelerator, at least to my understanding, and look, I've probably seen no more than what you have, right, on the net with regards to Bob Lazar. My interpretation was that he didn't claim that he needed a particle accelerator for anything. He just happened, he's a guy who's just got interest in physics.
Sorry to interject. It was a key part that it was to create some part of this oxidization, crystallization in the hydrogen container of the storage for it to be run on these hydrogens. Maybe it was graphene or something like that that had to be made in his particle accelerator to store it, where it's like just that complexity is just so ridiculous, because literally all you need to do before your fuel injector is have that H2O with a little salt in it, get a little shock of voltage, and it will turn into those gases before combusting.
Well,
you don't need to store that hydrogen to begin with, yet alone create the graphene to have to then make it, sort of thing. And I'm just saying it seems like it's the same with this element 115 and all of that, that it's like just over complexity, but where's the actual evidence of it all?
Yeah, you're describing kind of a Rube Goldberg thing, right? That would be your concern. I mean, sorry, Riccardo.
Look, certainly to my eyes, pardon me, in the element 15 and the propulsion space, and specifically the claims that he's made, I don't see complexity at all. In fact, I see absolute simplicity. I don't think there's anything difficult at all about it or complex. It's horrendously simple if it's actually real. It's just
Riccardo,
the simplicity is.
It was Moon. He was the nuclear chemist of Americas in the 1980s. He's actually got work that does support what you're saying in regards to how you're deciphering what Bob was saying with that. And in no way am I trying to attack your work. Your work is absolutely excellent, and that it's all, there's truths in everything, and it's figuring out each piece of this scientific puzzle, and that we have to test it, come up with it, and that is the scientific method.
Yeah, well, and I look at Riccardo's work in the same spirit as Paul Potter, right? Where he's looking at it and saying, okay, how could this work, and how many pieces match up, and you know, if there's smoke, is there fire, you know, and And I think none of us are ever going to find definitive evidence of that from the story that's been told. But it sounds like he's finding, well, there's smoke here, and so that this is probably worth more consideration.
Yeah, that's a good way to describe it, Tim. Absolutely. So look, I don't know whether Bob Lazar is telling the truth or not. I believe he is personally, right? But like everybody, I want evidence, but evidence that I can actually verify for myself, not what's told to me by someone else. And that's what I tried to do.
Yeah. Well, Riccardo, thank you so much. And we have about 4 minutes left, I think, in our Q&A session. I'm not sure if anybody.
Michael's got a question.
Oh, Michael does. Okay.
Michael.
Michael will close us out, I think. Go ahead, sir.
Cool. Yeah, I just had to jump on because it seemed people were unaware of. So it's not just isotopes. That's the thing. It's possible to have nuclear isomers. So you have a number of neutrons and protons, but you also have a nuclear excitation, which may stabilize a nucleus. So you could for example, you can have tantalum 180-M, which tantalum 180 is actually unstable on its own, but when you add a gamma ray of the proper frequency, it actually stabilizes the tantalum 180. So the isomer is stable, even though the isotope is not. So it's possible there are undiscovered nuclear isomers of element 115. I mean, probably impossibly difficult to prove, but that it's just the search space is bigger than just isotopes.
That's a really good point, Michael. I'm glad you brought it up. It's a really good point. I'm glad you brought it up.
Yeah, there's hafnium 178-M and 180 tantalum 188-M, and it's quite possible there are others that are yet to be discovered that are most nuclear isomers are less stable, but especially where there's like high nuclear spins, there's an opportunity to produce stabilization with isomers. And if I'm not mistaken, bismuth and also moscovium should have a decent amount of nuclear spin, some isotopes of them at least. So anyway, that's just a thought.
No, thanks for that, Michael. It's actually a really good point about the isomers. I'm glad you mentioned that. Well done.
Yeah, there's a lot here. Well, Riccardo, we're just about at the top of the hour. So, sir, I want to thank you personally for taking the time to present. And let me put this on speaker view, and I want to have everybody here clap and give Riccardo Storti a giant applause. Sir, thank you. That was a good depth, a good overview of the work. You've done a ton of research, and you've tried to kind of put method to madness, I think, where you've taken this story and tried to flesh it out. So thank you very much.
Yeah, that's exactly right. And I just might make a point, just in closing out, the ResearchGate article that you sent the link out. There is literally 30 years work in that. Literally 30 years. It's taken that long to produce those answers. So, and a lot of that journey was with Todd. So, he can take credit for it as well.
Well, yeah, no, I can't, sir, I cannot thank you enough for presenting for us. And we'd love to have you back as well. But so for right now, without any further ado, it's at 3 p.m. Let me go to Todd, who I just saw. Todd, are you with us?
I'm here.
Okay. And we are about an hour ahead of schedule, but and let me see.